All right, go ahead and take a deep breath. Feel that invisible rush of air filling up your lungs? It's kind of a quiet miracle, right? And you do it over a dozen times every single minute. But what if I told you that the very gas keeping you alive right now was actually once a deadly poison? A poison that caused a near-total planetary apocalypse. Welcome to this explainer, where we're going to explore the mind-blowing history of the Great Oxidation Event.
So picture this. Imagine standing on Earth roughly 2.7 billion years ago. Honestly, if you were there, you wouldn't survive for more than a few seconds. The atmosphere had absolutely zero free oxygen in it. None. And to the microscopic organisms that totally dominated the world back then, oxygen wasn't some life-giving necessity. It was a highly reactive, completely lethal toxin.
The contrast between our world today and that ancient Archean eon is just wild. If you looked up, you wouldn't see a nice blue sky. No way. You'd be staring at this deep, hazy orange sky because the air was incredibly thick with a greenhouse blanket of methane. And the oceans, they weren't blue either. They were a murky green, totally stained by massive amounts of dissolved iron. It was a completely alien world, but it was absolutely perfect for the life that lived there. See, for the first 2 billion years of our planet's history, the entire biosphere was anaerobic. We're talking about single-celled organisms, simple prokaryotes that thrived on chemicals like sulfur, iron, and methane. To them, oxygen was the ultimate killer. It would literally, chemically strip electrons right off their molecules, shredding their DNA and rupturing their cell membranes. They had spent over 1 billion years perfectly adapting to this oxygen-free zone. But as we know, evolution doesn't just sit still.
Which brings us to part 1, the unintentional killers, and the biological hack that changed everything.
Let's meet what are probably the most consequential organisms in the history of Earth, the Cyanobacteria. You might have heard them called blue-green algae. Sometime around 2.7 to 3.5 billion years ago, these tiny microbes figured out an incredible biological cheat code. Instead of scavenging for scarce chemicals to eat, they figured out how to hack sunlight. They started using solar energy to split water molecules apart, giving them basically unlimited energy. But breaking apart H2O meant they had this completely useless waste product left over: molecular oxygen. It really is the ultimate cosmic irony. Think of it like a factory that makes, candy, but pumps out a deadly nerve gas as its exhaust. Cyanobacteria were just going about their day, happily multiplying in the shallow coastal waters, all while accidentally pumping out a toxic exhaust that was slowly poisoning the entire planet. They were the ultimate unintentional polluters. So, you might be wondering, where did all this toxic oxygen actually go?
Let's look at part 2, the ocean rusts, the planet's giant chemical sponge.
Now, you'd probably assume the atmosphere just immediately filled up with oxygen, right? Actually, there was a huge delay, and it lasted for hundreds of millions of years. Remember those green oceans? They were completely saturated with dissolved iron, and that iron acted like a colossal planetary sponge. Every single time a cyanobacterium released a molecule of oxygen, it immediately bonded with the iron in the water. This reaction created iron oxide, basically rust, and that rust just sank to the seafloor, layer by layer, century after century. The crazy part is we can still literally see this today in the geological record. We call them banded iron formations. They're these massive layers of reddish rock that we mine all over the world. So think about this. The next time you see an iron bridge or a giant steel skyscraper, you are actually looking at the fossilized rust created by the breathing of those ancient microbes billions of years ago. It's literally their exhaust holding up our modern world. But of course, a sponge can only hold so much water. And that brings us to part 3, the oxygen catastrophe, a sudden global apocalypse. Around 2.4 billion years ago, that iron trap was finally full. The oxygen had nowhere left to go but up, so it started flooding into the oceans and the atmosphere. And as this highly reactive gas swept across the planet, it violently destroyed the unprotected cells of all that anaerobic life. It's estimated that somewhere between 90 and 99% of all living organisms perished. Let that sink in. 99%. It was Earth's first and quite possibly its greatest mass extinction. But wait, the disaster didn't even stop with the poisoning of the biosphere. The newly freed oxygen started aggressively reacting with the atmospheric methane. And remember, that methane was the vital greenhouse blanket keeping the early Earth warm under a sun that was actually 20% dimmer back then.
So as the oxygen destroyed the methane, the planet's thermostat completely crashed. Temperatures plummeted, global ice formed, and then that white ice just reflected the sunlight right back into space. This drove the temperatures down even faster in this catastrophic rapid feedback loop. Geologists call this the Huronian glaciation. Basically, Earth transformed into a giant snowball. Average surface temperatures crashed to -40 degrees, and it stayed like that, totally locked under a thick shell of ice, for 300 million years. Life was compressed into the darkest, most isolated refuges you can imagine. Deep-sea hydrothermal vents, underground hot springs, just barely clinging to existence. Even the cyanobacteria nearly wiped themselves out in the deep freeze. But life is incredibly resilient. Eventually, over millions of years, volcanoes pumped enough carbon dioxide back into the air to finally melt the ice.
Which leads us to part 4, the legacy of survivors. How an ancient apocalypse bred complexity.
When the ice finally thawed, the survivors woke up in a permanently altered, completely oxygen-rich world. They had to adapt, or they had to die. But for those that did adapt, the reward was absolutely monumental. Just look at the sheer biological upgrade that aerobic respiration provided. Burning glucose without oxygen gives you just 2 units of cellular energy. But using oxygen, that yields up to 38 units. It is literally the biological equivalent of upgrading from a horse-drawn cart directly to a steam engine.
This massive abundance of new energy changed the rules of life forever. It allowed cells to grow larger, move way faster, and eventually start sticking together to form complex multicellular organisms, like us. Plus, all that oxygen in the atmosphere formed the ozone layer, which blocked out deadly UV radiation and finally allowed life to leave the deep oceans and colonize dry land. It even transformed geology. Oxygen reacting with rocks pushed the number of mineral types on Earth from about 500 to over 5,000.
But honestly, the most profound legacy of this entire event happened on a microscopic level. To survive in this highly toxic new world, a larger, struggling anaerobic cell actually swallowed a smaller oxygen-breathing bacterium. But instead of digesting it for lunch, they actually merged. The tiny aerobic bacterium provided its new host with massive amounts of energy, while the larger host provided a safe, protective bubble. This biological merger is a process called endosymbiosis, and it created the very first complex eukaryotic cells.
And those tiny, engulfed aerobic bacteria, they never disappeared. They evolved into mitochondria, the powerhouses of your cells. They actually still have their own separate DNA today. That means every single heartbeat, every movement, and every thought you're having right now while watching this explainer is directly powered by the microscopic descendants of those ancient bacterial survivors living right inside your own cells. You are quite literally built from the survivors of Earth's very first apocalypse.
So, the Great Oxidation Event really proves that life doesn't just sit passively on a planet. Life fundamentally shapes the planet, the atmosphere, the climate, the very rocks beneath our feet, all engineered by biology. So, the next time you take a breath of that once deadly gas, ask yourself, if microscopic bacteria with no brains or intent could unintentionally terraform a planet and cause a global climate catastrophe just by releasing waste, what profound lessons does that ancient history hold for humanity's impact on our Earth today?